Here goes a video on systems of quadratic inequalities. So if you're watching this video, there's a pretty good chance you already know how to graph a quadratic. So this video is not going to go over how to graph an actual quadratic function. This is just going to specialize in the inequality part and finding a region that would solve a system of quadratic inequalities. Okay? So y is greater than or equal to 2 times x minus 3 squared minus 4. So again, if you know how to use vertex form to plot the vertex and find a few other points, that's great. If not, you just want to type it into y1 of your graphing calculator and press the table, and you'll be able to find some nice easy points to plot. So what I'm going to do here is I'm going to plot some of the points you would probably come up with. And I'm just going to quickly sketch this graph. I'm not going to go into detail of all of the exact points. What I'm going to do is I'm just going to sketch the parabola. Now I want you to notice that I used a solid line. Just like when you're graphing linear systems of inequalities, if you have greater than or equal to or less than or equal to, you're going to have a solid line. Okay? Now for the next one, we're going to have y is less than a negative x plus 2 times x minus 4, which is an intercept form. If you remember how to find the intercepts, we're going to have one at a negative 2 and at positive 4. And again, I'm not going to go through how to graph every single aspect of that parabola. The point of this is, after you know what to graph, how do you graph it? So if y is less than, this is an inequality that we're going to graph where the line does not count, so we have to use a dashed line. Okay, so that's how you graph the individual parabolas. If it's greater than or equal to or less than or equal to, you want to use a solid line. And if it's less than what you want to use or greater than, you want to use a dashed line for your actual parabola. So now we need to talk about shading. When you shade, what you do is, if y is greater than, you have to think about where does y get bigger, and it's above the line. So for the first parabola that we graphed, we would be shading above the line that created that parabola. So in this case, we would just pretty much be shading inside of that parabola. And then what we would need to do is the same thing for the second one. So if y is less than, you would think that y is getting smaller, is below the line. So we're going to shade below this parabola. And as you can see, where it turns green, yellow plus blue is equal to green, we have our solution. Okay, so a solution to this system is anywhere that takes place inside of this shaded region where they overlap, or on one of the lines on that shaded region that's solid. So to give you an example, 3, 1 would be a solution because it's in the overlapped shaded region. An example like 1, 2 would be an example because it's sitting right here on this solid line. Any place out in the blue is not a solution. Any place out here in the yellow is not a solution. Any place out here in the white is not a solution. Okay, so those are not solutions. But also, if you were right on the dashed line, that would also not be a solution, because you are on a dashed line, not a solid line. Okay? So in terms of quadratic inequalities, it's very similar than when we were talking about linear inequalities. It's got to be on a solid line that's on the shaded region or somewhere inside the shaded region. Okay? So the second example is for you to try on your own. Again, just pause the video, give it a try. You just have to graph 2 parabolas and shade them. And as soon as you are ready, click play, and we will show you what your solution should have been. So the first one, you have 2x squared minus 6. Your graph would look just like this. . and you would have a solid line, and you would be shading above that one because y is greater than or equal to 2x squared minus 6. Your second line, what you would have is a dashed parabola, and it would be a lot wider. And we're also going to shade above that. So however you came up with your graphs, what you need to have is just the inside of both of them. That would be your final area. Okay? So just in between the purple, but above the red parabola would be your final answer for this quadratic inequality. All right, so that's it for this one. This is Longo, and I'm out. See you, bye.